Hello and welcome to another video. In this video we're going to be doing shortest subarray sum with at least k, and we're going to do this live as well, so I haven't finished it before. I did take a few minutes to read over and think of some stuff, but that's about it because I didn't want this to be too long. But in this one you have an integer array nums and integer k, return length of the shortest non-empty subarray of nums with sum of at least k. If there's no such subarray, return -1. Subarray is a contiguous part of the array. Okay, so basically just return the shortest contiguous subarray with sum greater than or equal to k. So here's just one element, here there's nothing, and then here there's this. So I guess the easier problem of this is if every number was positive, right? Because then it would be super easy, it would just be a basic sliding window, because everything is always increasing. But here it's not always increasing because we have negative numbers. So I think what we want to do is we try to want to maybe have some kind of this only increasing thing as well. So for example, let's say our answer array is positives and negatives. We're never going to want to have something like this, right? So if, let's say we have two positives and a negative, because we can just remove the negative. If this is bigger than k, so is this. Same thing here. So I think maybe what we can do is we can store totals or something in some way, and then only store increasing totals. So then it would be kind of like the same problem as before, where every single number is positive. So for example, if we have something like 1, 2, -5, 4 or something, this'll never be good to use because this is negative. So if there's something past this, I guess this still might be used, but we're never going to use an array like this, essentially. So if any part of our array gives us a negative number, we can just shrink it. So then we want to think, how can we store these sums and these, increasing sums? So maybe a stack or a deck makes kind of some sense. So essentially we can just store increasing sums. So we can store a sum of 0, 1, 2, whatever, and then think of what cases we run into. So for sums, I guess we can either use prefix sums or calculate this on the fly, but essentially for a sum, using prefix sums to be greater than or equal to k, ideally the sum is just going to be our current element minus some previous element. So we want this previous element to be as small as possible. So let's think of some cases. So if our total decreases, let's say this is our prefix sums, if this is actually -5, let's say, then I think these are going to be useless, because if this is the start of a prefix sum, we want this to be as small as possible. So if anytime, that's the reason we want to keep increasing sums. So basically it'll be a monotonic increasing stack, I think. And then if anytime we get to elements that are smaller than ones we already have, we can get rid of these, because if we have some element in the future, this is the left side of the prefix sum, and we have some right side, the prefix sum is always going to be our current index minus the previous index -1. So for example, if we have an array of some numbers, and we want the prefix sum of this, it's going to be the total here minus the total here. So we want the total here to be as small as possible. So if the total here is very small and total here is bigger, that means our array looks like this, for example, which means that because we're subtracting a left, that means we're going to be subtracting this number minus this number, but we're never going to want to have something like this, right? So this is basically going to mean, in the case where we have some big negative numbers, we want to have our left side of the prefix sum as small as possible to get this thing to be as big as possible. So I guess the strategy would be going to the right, only add numbers that are bigger. And I think we can kind of shrink our window to the left, kind of like the simpler problem where all the numbers are positive. So if we do have let's say we have increasing sums 1, 2, whatever, and then we reach some sum of 50, and let's say 50 minus 1 is greater than k, then we can shrink our window, meaning we can get rid of the sum, try this, shrink, shrink, shrink. So we can maintain something like a total index or index total, and we can just keep doing that, shrink our window, and then if we don't have a result, we can return it. So let's try something like that. See if get somewhere. So let's use a deck, I think. And we're going to have two things, so we can call this window. And just like a normal prefix sum, you want to start out with the empty array. So we'll add. Let's add this. Like add. I don't know. Okay. And then this is going to be. So I guess we can make the array total index or index total. I guess we'll go with index total. So this will be index -1 and total of 0. So yeah. So you should know like basic prefix sums before doing this problem. I would say basic prefix sums, basic like DEC, stuff like that. Okay, then we'll make our result equal to like max val. Yeah, and then we can shrink it. And then we're just gonna go through this and only add increasing sums, I think. So they can be negative sums, that's fine, but we only want to add increasing sums, I think. So let's see what happens. The idea, like I said, is the prefix sum calculation is basically your current index minus the index where you want to start the array minus 1. And so we want that previous value to be as small as possible to give our array the biggest value possible. Okay, so is this the nums length? All right, so we can calculate the total on the fly, I think. We don't need to store it, probably. Let's see what happens. If we do, we'll do something. Okay. So essentially, basically, we want to say, while we have this DEC, and our previous total is bigger than our current, we want the smallest current total possible, plus our previous total is further away. So it would never make sense to use a bigger previous total that's further away. It'll be a bigger array that's further away, which is bad. So we can just say while window is not empty. Yeah. So while window is not empty and window get last at index 1 is the total is bigger than or equal to, because equal to is also worse because they're going to give you the same sum, but this is bigger. Total, we can just pop from the right. Yeah, pop from the right. So remove last or something. Okay. And then we're going to add this current total onto our window. So window add. Yeah. And then this will just be new int array at index I with a total. Okay. So now we have like this increasing window. Now we need to check, is our current sum minus our smallest sum, which is going to be the leftmost sum, bigger than k? And if it is bigger than k or equal to k, take that result and keep popping from the left. So essentially if our sum looks like 0, 10, 20, 30, 40, and our k happens to be like 50 or 40, let's say. So this will give us 40, or let's say k is like 30, 35, I don't know, whatever. So this will give us a big enough total, and then we basically say like this sum minus this sum is big enough. So then let's get rid of that and let's try this, and so on, and so on, and so on. So we'll just keep popping from the left. Because if this array is big enough, then like adding on, why would we? That wouldn't make any sense. So we need to shrink it until it's no longer big enough, basically. Oh, so we can just say while. So we need to have at least 2 elements here to make a sum. Yeah. The only way it would work with 1 element is if you had this. So I guess we can have a case here. So we can just say like if nums I is greater than or equal to k, just return 1 because like that one number is bigger than k, and then we're done. Okay, so while it's 2 items, so while window get size, or yeah, greater than 2, and window get last 1 minus window, just full screen now, get first 1, it's greater than or equal to k, maximize our result. So this will be very similar. Get last 0. Get first 0. Maybe we have an off by 1. We'll see what happens. And then basically shrink from the left now. So window pop left or something. Pop, pull first. Okay. Yeah, and I think this is good. Let's see if we run into any errors, and then we can just return result equals max value. So if it's max value, we didn't find anything, so let's return -1 in this case. Otherwise, result. Let's see what errors we got. Okay, we got a wrong answer. And so we get -1 here. So I guess let's walk through our code for this case. So did we add the 0? Yeah, so 0 at index -1. Okay. Are we increasing our total? Yeah. Okay. Yeah, so it looks like we never found anything, which is interesting. Get last one. Oh wait, this should not be 1. This should be 0, right? It's the index. Actually, no, that's fine. Yeah, because it's index total, right? Let's see. Yeah, index total. Okay, so if we go through this example in pseudocode, I guess, let's walk through what would happen. So our total is going to be, like, at first, we'll just do this. This will be the first item in here. Let's get rid of this auto. And then afterwards, we're going to increase our total to 2. Will we increase our total? Yes, it'll be increasing. So increase our total to 2 at index 1. Then we're going to check, or actually the other way, index 0, total 2. Okay, we're going to check, is this greater than or equal to k? It's not. So we just keep going. Okay, for this -1, now our total shrinks. Right? Yeah. Yeah, our total shrinks. So that means we're going to delete this case. And we're going to add our new total of 1 at index 1. Okay, and then we're going to check this difference. And it's not going to be, it's the only difference of 1. So we can't do anything there. And then our last total is going to be 3 at index 2. So then we should hit this case. So if this is greater than or equal to k, it is max result get last 0 minus window get first 0. Yeah, and then we should get a 3 here. Yeah, then we pull from the first. I wonder if remove first. I don't know if that matters. Okay. Yeah. Okay. And if this is this, so it's max value. Oh, do we max it or something? Or do we min it? Oh, we want to min it. That's what it is. Okay. Yeah, let's get rid of that. All right. Oh. K is some big number. So this is probably some overflow thing. Guessing. So maybe we do want to use like long or something. Long. And long. And then total. Let's see if you get any type errors somewhere. Okay. Long. I guess we could convert. So let's see, this is going to be long. Result. Okay, we're getting an int array. I wonder if this just hasn't updated yet. I don't think we're using, oh, this needs to be long. Okay, well actually, that should be fine, actually, int. Or we could do long and then we can just convert it back to an int or something. It's also fine, probably. Let's see if we get an error. Okay, type mismatch cannot convert from long to int. Okay, let's see if that worked. Well, let's add this test case. I'm guessing it's just like an overflow. Okay, cool. Yeah, I mean, you can probably like make a tuple or something to make this cleaner, but essentially, yeah. So the logic makes sense. Like, we're basically trying to only have increasing sums to kind of have that same pattern as we have for the normal subarray sum equals k or greater than k, shortest. So basically, we are just only storing increasing sums because if you have a decreasing sum, you don't want to store it. You want to just be you want to just be getting rid of old stuff essentially, and this is the whole point of, like I said, the prefix sum is the current index minus the starting index minus 1. So because we want to minimize this, anytime we get something farther down that is smaller than what we had, we just want to be popping. And a deck makes sense. I think maybe another way you could do this is not popping, just use a stack only and then like binary search, because your sums are all in increasing order. So you can probably just like binary search for like what's the smallest one. Yeah, maybe other ways, but this seems pretty good. Okay, so this is linear. Kind of hard problem, I guess, to be honest, because you have to use a monotonic stack. I mean, your monotonic stack's pretty rare. But yeah, the main thing is just recognize like how does a prefix sum work? How does, you know, like what constraints do you want for the shortest arrays possible? Things like that. This is definitely kind of messy. Let me know if you guys like this format for harder problems. Like, yeah, it might just be not as clean as me doing it beforehand because I'm kind of like trying to figure stuff out. But you do get a more realistic, you know, like what things are expected to look like instead of like, let me do it and get a perfect solution and then like explain it and stuff like that. So if this is unclear or something, I can go back to the old format. But yeah, let me know what you guys think about this one. And that's it. So yeah, thanks for watching.